We began this course with a look at text analysis. In this lesson, we'll go a bit deeper into this topic and introduce how to implement a custom analyzer to modify your indexing processes. Let's briefly review some concepts behind text analysis by looking again at how a phrase like this might be indexed. It starts with tokenization. In some fashion, the incoming text stream must be chopped into individual elements. But how does this division occur? Would you analyze a sentence the same as a stream of HTML? Do you leave punctuation in place or strip it out? And then what might you do? Does it make sense to reduce all terms to a common case? Not all languages treat letter case in the same way, leading to distinct analyzers for different languages. You might also need stop words beyond the obvious removal of the, or, and so on. For example, is there any point in indexing the word wine in a bucket full of documents that are all about wine? Next, we've seen how it makes sense to reduce words to common stems and to conform common spelling variants to a single stem. But once again, how you do so would vary greatly based on your language. Because in the end, what you want is the most useful possible set of stems in your index. As we've now seen throughout the course, text analysis is applied to your documents, resulting in common stems. But that same analysis is nearly always also applied to the incoming search terms, so that the same stems are being searched as have been indexed. So what is this element being analyzed? Well, it's tokens. A token is essentially comprised of a term, a document reference, and an offset position within that document. Different analyzers, though, will make different choices about tokens. For example, the standard analyzer would chop an email address into 2 tokens, while the web analyzer would leave it intact and create a single token for this term. Similarly, the web analyzer would treat URLs, tags, handles, and hashtags differently, commonly by leaving punctuation in place rather than stripping it out. There are multiple built-in analyzers, with the standard analyzer being the default. There are also several built-in language-specific analyzers. Additional analyzers can be built by configuration, as we'll see in a moment, or implemented via code. A custom analyzer can be built by configuration and layered on top of other analysis. It will include a tokenizer to determine how individual terms are extracted from text, and may include one or more character filters to strip unwanted characters from those tokens, and then one or more token filters to strip unwanted tokens during analysis, possibly based on character length or based on a customized list of stop words. There are other filters as well, and you can also code your own. Token filters may rely on custom word lists you define, and this whole token filter pipeline is then given a name so that it can be selectively applied within an index. Each index has a default analyzer, which applies to all text, whether for searching or indexing purposes, unless it is overridden by another analyzer at some level of that index's mapping hierarchy. Each type mapping in the index inherits its parent analyzer, which may well be the default analyzer, which by default would be the standard analyzer unless you change this. But any given mapping can be overridden by a different analyzer, whether it is a built-in analyzer or a custom analyzer you define. In the upcoming lab, we'll step you through this entire process. So what have you learned? Well, analysis boils down to tokenization and filtering. A token is essentially a term plus its document ID and offset position within that document. An analyzer is a tokenizer and a set or pipeline of filters, character filters, token filters, and so on. The same analyzer will normally be used for both indexing and searching. Each index has a default analyzer, normally the standard analyzer, which is inherited by each of its type mappings and all child mappings. However, Each mapping can override the analyzer it inherits from its parent. In this lab, we will walk you through building a custom analyzer to filter out stop words specific to the wine search documents, because again, how much sense does it make to search for the term wine when it's likely in every single document? But as you do this, you'll see a lot of other choices you could make in building out analyzers, and hopefully you'll choose to experiment a bit. With this lesson, we've reached the end of this introduction to Couchbase full-text search, but there's a lot more for you ahead if you want to continue studying Couchbase. To keep diving in, check out the rest of our free online training. You may want to explore how to model your data in JSON and manipulate it with Nickel. We also provide classroom training, conferences, documentation, blog articles on focused topics, and more. Thank you for taking time to learn more about Couchbase. We've got you covered.